Hi, I'm Caroline. Once you understand what a mole is, the next step is learning how to calculate them. In this video, we'll go through how to use the equation involving mass, molecular mass, MR, and moles, with clear guided examples. By the end, you'll be confident using this essential formula in exam-style questions. Pause and have a go as we go along, and don't forget to subscribe for more no-fluff walkthroughs of every single GCSE chemistry calculation you'll need. Let's dive in. Now let's start off with a brief refresher of what a mole is. Now I go into this in depth and calculating an MR in other videos in this playlist, so don't forget to check those out if they will help you. But quite simply now, a mole represents a number, a really big number, 6.02 times 10 to the 23. If we have that number of something, we have a mole of it, 1 mole of it. Now, if you're an A-level student, then don't forget to check out the significant figures given in these questions. And sometimes that will include the number of significant figures they perhaps give Avogadro's number to. So the equation that we're going to use, and then I'm going to talk you through a load of guided examples so you can get really confident about how to do this. The equation is moles is equal to the mass of the substance in grams divided by the MR, the formula mass. Now, you need to be able to rearrange this equation, which is where the triangle comes in. If it helps you, you can use this triangle to help rearrange it. All you do is cover up what it is that you are trying to find out. So for instance, if we're trying to calculate moles, then we cover up moles in the triangle, and that leaves us with mass over MR. So moles is equal to mass divided by MR. I like to remember this triangle by thinking it's mass over Mr. Moles. And you can see that in the little cartoon right there. Mr. Moles being squished by a very heavy mass. Now let's look next at the standard units that we need. So the standard units are grams, mass in grams, which means we always have to convert to grams. I cannot stress that enough. It doesn't matter if you end up with the correct answer overall. If you have not converted to grams in the midst of the question, the calculation, whatever it is that you're working with, it will be marked wrong because you will have the wrong number of moles throughout. So you always have to convert to grams. Here are some common conversions that we'll meet and that you'll meet in exam questions. So starting off with milligrams, they're the tiny little ones. We have 1,000 milligrams in a gram. The next one is kilograms. 1,000 grams fit in 1 kilogram. And then finally, tons. Tons you can either think of, there are 1,000 kilograms in 1 ton or 1 million grams in 1 ton. And you can see there in the middle column how to apply that. So to go from milligrams to grams, we divide by 1,000. To go from kilograms to grams, we times by 1,000. And to go from a ton to grams, we times by 1 million, 1 and 6 zeros. Let's now have a go at using this equation. Remember to hit pause if you want to have a go at it before I work it through and explain it all the way to the answer. So we're going to start off by rearranging the equation. Now, if you struggle to rearrange the equation, then the triangle is a good way to do it. The way to remember it is here's Mr. Moles is being crushed by a great heavy mass. Now, in order to use the triangle, all you do is cover over the one that you are interested in finding out, which here is moles. So that means moles is equal to mass divided by the MR. Now, we're told the mass, it's 85 grams. It's already grams, it's our standard units. And then we're going to divide that by the MR, which is 18. 16 plus 2 lots of 1. That gives us an overall answer of 4.72. And there are no units there because moles, remember, represents a number. So there's no units. Starting with the same rearranged equation here. So moles is still equal to mass in grams divided by the MR. We have a little bit more to do here because our mass was actually given as 2 kilograms. There are 1,000 grams in a kilogram. So to convert that into grams, I'm timesing by 1,000, that gives us 2,000. We also need to work out the MR. Now, there is a full video on this that I have made if you want to brush up on that. But for this one, right now, we are going to use the periodic table to find the AR of the potassium, which is 39, and times that by 2, because there's 2 in the formula, and add that to the 1 oxygen. That MR is therefore 94. Now we're ready to come back up here and put it into the equation. So the 2,000 grams divided by the MR of 94 gives us an overall answer of 21.3 moles with no units because moles is a number. So first we need to rearrange the equation. Mass is equal to Mr. MR moles times by moles. In order to work out the MR, we're going to take the 1 nitrogen, 14, and add that to the 3 hydrogens. So the MR of the ammonia is 17. Now let's put this back into the equation. So 17, the MR, times by the moles, 0.1, gives us overall 1.7. And this is mass, so don't forget your standard units, 1.7 grams. Still working here with mass is equal to Mr. moles. Let's calculate our MR first. So our MR, use the periodic table. We have 1 aluminium, 27, 3 oxygens, 3 lots of 16, and 3 hydrogens, 3 lots of 1. Our MR is therefore 78. Putting it back into the equation now. So 78 times by the number of moles given to us, 0.4. That gets us to 31.2 grams, not forgetting units. So this one might read a little bit scarier, but it's not. We're going to follow the same idea, first of all, of rearranging the equation so it's MR equals. Cover over the MR in the triangle, and that leaves us with mass divided by moles, both of which were given. So let's go right ahead and put those into the equation. 3.28 grams, already in standard units, divided by the 0.02 moles. That gets us overall to 164. That's your overall answer because MR does not have any units.
Thanks for watching. And if this was helpful, don't forget to hit subscribe now for new GCSE and A-level chemistry videos to help you through your exams.